I want to start off this week's episode by just showing you a tour of kind of my workplace. Kind of my desktop. And this is the background that you're seeing. This is my background. You can see that this is the themes and stuff. If you look at the color choice up here, and just maybe even open up the Finder for you, just to show you how it looks like. Just open up Downloads for you. So this is kind of how this is kind of the theme of my desktop, and you see that this also translates into Visual Studio Code. You look at the color that you have here, and I've also added a few other sort of like my themes, and I script it very heavily just to have this very harmonious looking work environment on my desktop. So this is kind of my note-taking application. If I show you how it looks like, just click on a few notes here, maybe the home. This is how it looks like: Markdown PDF, home, and space theme, macro. That's all of this. But if you notice one thing, is that the colors are pretty consistent across the different spaces that I'm moving from. So this is Visual Studio Code. That was my note-taking application, and this is kind of my terminal, my shell, right? This is my terminal, and this is kind of where I work most of the time. And if you look at the color choice itself, they come to very similar to each other. So you see this is the same kind of blue, the same kind of color choices and stuff. And the reason I want to bring that up is because this week's episode, we're gonna just focus on building a better customer experience. We're gonna add some colors to our terminal, and we're gonna stick to the theme of the series, which is that we're not gonna introduce any external dependencies. So all of this is just gonna be what you get out of a straight, clean Python installation, right? So we're just gonna try to keep our package really lightweight. We don't want to introduce 500 megabytes of numpy, pandas, matplotlib, all of those things. Even when we do charting later, we try to not use anything outside of that. We have to write our own charting script and stuff. So this is kind of it's gonna be a pretty fun, I think, series. And this week we're just gonna focus on building a better customer experience. If you notice a couple of things, is the first thing, we still try to hard code our location. TaskWarrior, when you first install it, it installs to a default location. I told you that I moved that location out to something in my words, and that's probably not a very standard choice for most people. This is not a very conventional choice, so this is probably bad practice. So what I want to do is I want to just remove all the hard coding in this episode, create a better tool with good structure, with good with proper folder hierarchy, file structures and stuff, no more hard coding. And also we're gonna try and see if we have time to start writing up some tests as well. But really the whole point is to just improve on what we've done last week. And if you actually have never written anything that is maybe like a Python module or Python tool or CLI application or a Python package, and you wonder, how do you want to structure all of these files together, because you're so used to seeing things in Jupyter Notebook, or you're so used to just opening a file and do all of this stuff, then I think this episode would be really interesting to you. So I'm really excited to get started. This is kind of what it looks like at the end of it. You have colors and stuff. We're probably going to add a few choices and add more colors to it, and I'll talk about that. But I hope you enjoy, and let's get started. So this is where we left off the last time. This is still in score.py, but before we get into any further, I'll probably want to give you a bit of background about how do you get colors from, let's say, on a terminal. And actually, this may surprise you, but actually on most terminals, it's actually possible to colorize your output using some sort of we call it an ANSI, A-N-S-I. I don't even know if I actually pronounced that correctly, but A-N-S-I, ANSI, and that's kind of a way for you to add effects to your text, and you can add colors to your text, you can make it bold, and so that's kind of what we're going to depend upon pretty heavily. So because on terminals it's possible to colorize outputs, but you're gonna have to learn a little bit of the syntax, and it's kind of awkward looking. But I actually have my terminal open up, and I feel like the best way to just show you what it looks like, right? So for example, I'm going to show you how to do it in Python, but let me just show you how to do it in Bash first. So this is actually G shell, but it's the same as Bash. So I'm just going to do a echo, and here it's just telling the terminal to just print it out to me, right? And I'm going to show you how it looks like. Now, if I just do a super type like this is just going to print out the text. Very boring, nothing fancy. But what if I want to give it a little bit of an effect there? So it turns out there are something, and maybe just write the term out here. This is called the ANSI, right? And again, I don't know if the word is actually pronounced correctly, but if you want, you can just search up ANSI escape sequence, and what it does is that it would look for all of the escape sequence, and it would just substituting the escape into that effect that you want. So let me show you what it looks like, right? So just to remind you, if I just print out super type, that's kind of how it looks like. Let me clear the screen to have more rooms to work with. And then in order to, for example, give it an effect, you would do something like backslash, and then you do something like 033, and don't ask me why it's 033 and stuff. There is a long article, I can point you to it on Wikipedia if you want to, and you can then end it. And end is pretty consistent. To end the effect, you would always use the same one, and the same one, it goes 033 and it's square bracket and 0m. Yep, it's pretty awkward looking, like I said. And now what this will do is that it gives it a color. It gives it a color, and you may think that this is so strange. How do you just give it a color by just doing that? Now, what happens here, the 033, just remember the first 4 characters of that, the backslash, 033, and the square bracket is always going to be the same. But here is kind of how you want to change the color that matters. So for example, if I don't want 31, I can have it as a green by changing it to 92. And don't ask me why I know it's green. I kind of have this memorized somewhere and put them on the notes here. So you can change that. You can also change it to be a different color. Let's say you want it slightly to be a bluish color. You can add 96. And now, I don't know if you can actually see the difference in there, but you can. There is clearly some. Let me change to 94. You can see the colors changes based on what is specified here. The end is always going to be the same. This is actually just saying like reset. It's basically just reset. So when you see something like, let me just add a comment in here. When you see something like 033 square bracket 0m, that's always going to be reset, meaning take away all the effects. So essentially I can do something like this, and I can change the type to be behind this like this, and you see that the effect only take place up to this point, because then it says, oh, reset. Alright, cool. So it resets, and then type doesn't take any effects that you have in the beginning. And you can mix and match them. So in a way, you can have 31m for super, but then you can also, for type, you can also have a kind of a different effect here. So you can say something like 033. You know what we can do? Even better is we can just have super, and then from here we can just do 033, 31. Let's give it blue maybe, right? 94m, and then we just have to write the word type like this, and then we just have to end it. So now you have super, red, and then the blue being type. So this is kind of how you add colors. I know the syntax is very, very awkward, but I'm probably not going to make you go through all of that. That's going to waste a lot of your time. So what I did was I did my homework before I started recording, and I kind of have it pull up somewhere already. And we're going to start off by just looking at a few more, and I want to show you what are the things you can do with this. Is you can actually combine the effect. So for example, 31m, this 31m here give you that rate. But do you know actually you can also you can give it a different effect apart from just coloring. For example, if you just have 1m, that would just bow it. So that would just give the super a bow effect, and then the type would just be a blue, so you now have a bow. And you can obviously combine them, so you can have for example 1m, but you also want the 033 to be somewhere in there. So 033, recall, is the red that is giving the effect of red here. So we know this is right. So let me just copy that. Control Shift Command to copy on Linux. Otherwise, maybe Control C, paste it. Now this is what we get from a red and a blue, right? And what we need to do is to just add a semicolon and then add a second effect on top of that. And in this second effect, let's say we want it to be bold, we can just add 1m. And now the red, it would just the red would still be there, but it will now be bold as well. Well, that's 1m. Another one you can do is 4m. 4m give you an underline effect, I believe, and that would give you the entire underline effect. If you don't want the whole underline, you need to reset that first and then set the blue color. But in this case here, we didn't do that, so you just go all the way. All right. So that's kind of how you do it. You can combine effect, and you can have as many effects as you want. So you don't have to stop at 4m. You can actually add just a 1 as well. So you want a bold, and you want to underline, and you want a color. So let me just add a semicolon so you can go as far as you want. Here you go, right? So there is the bold, there is the color, and then there is also the bold, the color, and the underline. So that's kind of how you do it. In Python, the syntax is a little bit different, but it's largely similar. So what you see in here, I can take all of this, I can just copy that like this, and I will just go into my script, and I can just do a print statement. And you just have to put them in quotes. I already did them, so you're just going to put them in quotes like this, and not even going to have to worry about that. And so what you see now is a print statement with the text up here that I just copied without the echo. Save it, and whoops, it keeps complaining about this. Do I want to install that? Do not show again, right? And what we're gonna do is we're just gonna run the script. So let's do that. Python score.py, and bam, now it appears super type. So you probably don't want to say that. You want to say super type score sheet, like this. So if you run it now, you now have the very pretty looking score sheet. Okay, so that's kind of how you add color effect. And I mentioned about this because this is kind of what we're going to be doing. We're going to use this a lot to make a very user-friendly terminal, good-looking terminal. But we're also going to combine that with a few other techniques I want to show you. And really what we want to do is to clean up all of this, because right now, obviously, the way it's set up, it's only going to be useful for us. It's not going to be useful for anyone else who is not having TaskWarrior configured the way that we have here. So that's not ideal. So how do we fix that, right? How do we give it a better custom experience, and it's not overly tailored to our use case? That's kind of a good product. What a good product should be is that it should be able to generalize to as many people as possible. They shouldn't have to worry about how they configure this. The application, the tool that you build should cater to people's need. So what we're gonna do instead now is that we're gonna try and maybe create the color and put all of this color into like an object. You can think of it as like a dictionary. It can be a lookup table in a way, so we don't have to remember all of this awkward syntax. So that would help us, right? So let's go ahead and just create a new file, and you can name the file anything you want. But actually, the file should actually be in utils, because if you it goes in there. So I already did the file, so I'm just gonna sort of cheat and just show you all of this stuff in here, because I don't want to waste your time to do that. I'm probably not gonna change too much from here, but I'm probably not gonna call it B colors either. So I'm gonna just say choose all of them, and I'm gonna call this text style, because it's not just background colors. I added a few text style. By the way, if you're wondering like how do I get all these colors and stuff, what is the name of these themes that I'm using and stuff, it's called Node. I use Node pretty heavily everywhere, and if I don't find a theme, I create one for it and I just use it and I script it. And I have a few here that we're going to be using, but if you don't like them, you can go and change it to whatever color you want, right? I'll give you a link. Actually, you can also click on one of these references, and you can find all the nice colors that you want and pick them and just swap them out. So I already created colors.py. There's really nothing fancy in here. It only has this one simple object in here. It's a class, and text style basically give you all of this so that you can go into import a py. So you can just go in here and just say from utils.colors, and you can just go ahead and import that. So what did we call it earlier? Let's you can just look. We quite quick text style. So import text style, and from here we don't have to worry about all of this sequence anymore. Instead, what we're gonna do is to do something much smarter than that. We're gonna put an f string, and we're gonna have text style and rely on the autocomplete to kind of show us what we want. And we're gonna have our bow, and then we're gonna also have our underline, for example, and whoops, text style, underline, and then we're probably gonna have, I think 2 of this effect is good enough, but if you want to have a color, you can do that. I actually like the cyan color that I have here, and I'm gonna say report, productivity report. Okay, and remember that we always want to end text style, because if we don't do that, it's just going to populate the rest of the text. If we don't want to do this, we want to just say, okay, this is where you end. Kind of like if you know markup language or markdown language. Markup language, you have the HTML, for example, but we're going to just reset like this. Now we save it. If we run the python score.py, we can see that, oh, there we go. We have the bow, we have the underline, and we have the color without having to very awkwardly remember all of this stuff. So it's kind of just a nice utility that just to keep it somewhere in there. So I save them under utils. This is colors.py. If you want to have the full script, this is all going to be on my GitHub. So just go on the GitHub and just copy that. I don't feel like it's going to be worth your while to, just spend the next 35 minutes just talking about each one of them. I feel like you could just do a quick Google search if you want to and learn more about that. You will see that I reference this very heavily throughout what I do later, because I don't have to then look at try to write out all the different ANSI score in here. All right, so maybe this command would be useful. So let's move it up here and let's type it in. Let's save it. And so this is kind of what we have at the moment. another important advice is that if you want other people to be able to use the tool, you want to actually have a requirements file, so people know what kind of dependencies is involved with this project, what do they need to install to get this application fired up, and to contribute to your project. So you can actually, I mean, I see a lot of people do that, right? Go touch requirements, the txt, and then I see them going in here, create a file like this, and then from this they start to write the requirements. That is not the right way to do it. Some other people will do a pip list, and then you'll see, oh, this is all I have in the environment. So there's the package, there's a black click, pip, tabulate, and what they do is they take that and then they append the requirements .txt, and when you do this, it just appends to it. Now this is also wrong. I mean, this is kind of, in a way, you're actually documenting that, but I've seen that before, and this is also not the right way to do it. So let me just go ahead and just remove that. And what you should do instead is you do 2 steps to that, right? The first step is you do a pip freeze, and you then take the output of pip freeze and you feed it into requirements.txt. So notice that this is now deleted, it's no longer there. And if we delete that, close that tab out, press enter, it's going to create that right away, and it's going to give you exactly what you need. And from here, you can actually just kind of very quickly glance through the list, and you can see like, okay, some of these you probably don't need the end user to actually be installing. You could, for example, remove this black, because black is just a formatter. You don't actually need anyone to have formatter installed in order to use your package. So let's just if there's something else you find here that you don't need, you can go ahead and just delete that. I'm just going to close this out now. So I have the requirements done, and I'm just going to speed the video up a little bit now to just do a bunch of sort of restructuring, just to do a bit of housekeeping, do a little bit of restructuring, keep this all in a right format. So first thing I'm going to do is that I'm also going to go create a folder that is called task1. So I'm just going to say make directory task1 within task1. So there is already task1, that's the project directory, and I'm going to create this itself is going to be the application module itself. This is where all the codes is going to go in there. This is where all the codes are going to be stored. So let's just go ahead and do that. And now I have task1 created. And within this is where I'm going to put all my files in it. So I will probably try and drag score.py and maybe drag it in there. And I'm also going to have a main file just to fire up things, anything that it's kind of the entry point. And I'm going to just create that under the task1 folder. So just say task1, and I'm going to say that's just going to be called app.py. Another way you can do that is you can do it main.py. Some people like to do it with the name as well and just call it task1.py. Now I just like to call it app.py to be really simple. Okay, and within it, because I want to make this a package, a directory, you should know what to do now, because we spoke about that in the last video, and that's actually creating the init.py, the dunder init.py. So double underscore is called dunder, D-U-N-D-R. Don't ask me who came up with that name, but it's called dunder. Dunder means double underscore. So let's go ahead and touch that as well. So touch task1 and init_.py. That would just make it a package on its own. So now we have the init.py, we have the app, and I feel like this is kind of the place to put score.py, because that is actually the core functionality of the package itself. So what we want to do is you can either drag this in there, or you can maybe just even create another directory and just call it score and move that in here. So for example, we can do make directory, and we can say task1, and we can just call it score. And so within score, we can store all the items that are related, all the objects that are related to score, and put it in here as well. So let's just maybe do that. And within it, so there is a score folder, and there is nothing in here. So let's go ahead and do our touch. So this is going to create an init.py and put them under score as well. And then we're going to just drag our score.py and drag it into score. But if I look at what score is doing, this is going to be a little bit confusing if I have score and I just put them into the score folder. So what I decided to do is, maybe at this point it's a good time to just rename this file. And we're just going to call it accum.py. Okay, just to mean accumulate, because at the end of the output, that's just creating an accumulated score. So once you have accum.py, this is just a rename of the initial file that we've been working on in the last episode. So what we need to do is to just sort of move this into score, just kind of like that. So in score itself, we have the accum.py, we have init.py, and if you look at the rest of the structure within task1 itself, we have the init.py to make this a module, and we have app.py. This is kind of the entry point. So when the end user or anyone who's trying to use our application, when they hit the, let's say they call Python and they say task1, they just have to worry about app.py, because then they can specify the rest of the arguments, the whatever they want to pass in here, and app.py is going to delegate to all the all the different core modules. So maybe we have a charting sort of sub-module in here, we have a charting, we have some sort of visualization, we have some sort of tabulation and stuff, and app.py is gonna be the guide to go and find all of these different sub-modules within the main directory itself. So that's kind of how we want to imagine how we set up this stuff. So I know it's a little bit confusing, and I know I sort of went through it pretty fast, so maybe if you want to rewatch it again, just pause and try to structure it up just kind of the way I have it here. And I would say at this point, I want to make sure that utils in here, there's colors.py, there's create table.py. So this is also a good time to make utils a submodule on its own as well. So you can go ahead and just do a touch again. Actually, if you want to, you can just right click and just say new file and stuff. But sometimes I do it on the wrong level and I just end up creating the wrong file. So I just got very used to just using it from terminal. So it's more precise and I don't have to worry about accidentally doing it wrong and I have to use the mouse and navigate around stuff. So I'm just gonna go ahead, say touch again, and what I want here, just to show you what I have in the folder, I have utils folder. So I'm just gonna say touch utils, and again dunder init dunder.py. So that's gonna make this also a submodule. So every time you see an init.py, that's what it's doing. All right. Usually you want to make sure that if this is something that you're going to put on GitHub and you want to have other people working on this project together, or you want to have people be able to download the tool and use the tool and build the tool on their own, you want to make sure you have at least a readme.md. This is kind of a nice way to sort of put what the project is about, describe the features a little bit, and maybe give a quick guide on like how do you start using the tool. So it's also pretty common to actually have something like a contributing file, so you may as well just go ahead and create that. Just good practice anyway. So contributing.md. So this is a little bit different from readme.md. This is specifically about if you want to contribute this project, what do you need to do and what kind of setup do you want to have and what kind of standards do we follow? Do we use PEP8? Do we use a black formatter? Do you use any kind of formatter at all? So this is also a good time to maybe just read up a little bit about contributing.md if you want to actually create an open source project and have other people chip in. This is a sort of a nice standard to have. All right, so you have contributing, you have readme, but in our case, we probably won't even need that, at least at this stage. So you're just gonna remove that and press enter, done. All right. Then I would say right now, if you just go into our score, go into app.py, go into our score. Let's take a look at our within our score. We have the accum.py. So now we have all of these features in here, and I will say off the bat, maybe the first thing I want to do here is to maybe change the main so that it's not called main anymore, because the main, if anything, it should be the app itself. So this accum.py, what it's supposed to do is to just create the accumulated score. So how much score do you get over all the different days where you're completing tasks. So that's probably, you want to name this to be somewhat indicative of what it's supposed to do. So I don't want to call it main anymore. I'm just gonna a quick way to do this instead of actually just delete that is you can hit Ctrl D and look at all the places where you have named it, and you can just delete them and just rename it. Another way is to just hover over this and on the keyboard press F2, and it would ask you to rename it, and you can just put a new name and say score accum. And when you press enter, what it's going to do is that it's going to rename all the symbols very intelligently. So it's like, oh, that's main, I'm going to rename that to score accum. So this is better than you manually going there and trying to change things into like a score accum and then finding all the different places where that has occurred and change that manually. That's going to probably lead to you forgetting or missing out on a few things. So you don't want to do that. Now, every time you try and change something like this, you want to maybe quickly check whatever file that is used to reference this, right? So maybe, is there an init file that you reference that? No, okay, that's fine. But generally, if you follow what I just did there with the F2 approach, probably don't have to worry too much about that. It would do that intelligently, providing that you're using a modern IDE. Okay, And let's take a look at app.py. This is kind of the main file we want to work on today. And so the first thing I want to do is that I want this to be the entry point. So if somebody hits app.py, it needs to fire up the accum.py. So what do? Now this is already a submodule because it has an init.py. So we can just directly import from it. We can say, okay, what is the name of this folder? Score. So let's say from score dot name of the file accum. So from score.accum import, and what is the name of the folder of the function? Score accum. So score accum. If the name here is different, you want to change this. Okay. So for me, I name it score_accum. So that's what I'm gonna have. And then you can just have a score accum. Just run that. Just execute that function. Just run the function like that. And to test whether all the restructuring has successfully take place, and make sure that we did not miss out anything, let's just really quickly go into terminal and just run the app.py now, right? So Python app.py, and actually app.py is not in this directory. It's gonna say task1 app.py. And it says what? From score.accum import score.accum, from utils.color import text style. It says there is no module name utils. So now it's a time to actually go into the accum.py and see where is it that we missed out. Utils.colors import text style, and the reason for that is because this is a relative path, and it doesn't find utils within the where we call it from. So that tells us that we didn't actually bring the utils into the right folder. And if you look at task1, this is in fact outside of it. So what we want to do is want to change this and move this into task1. Did we move it correctly? So now we have score, we have utils. So under task1 there should be score and there should be utils, and within score itself it should be there should be init.py and there should be accum, and then utils itself there should be your colors and stuff, right? So all of this is in the right package, and then you have app.py being the entry point. So that's kind of why it's complaining here. So no problem, no big deal. Let's clear the screen again, just to show you how the tree structure looks like now. This is how it looks like, right? Readme requirements.txt. These are really good to have, especially if you want to have this being more than just a project that you yourself use on your computer. You want to have other people use your project as well. You want to have readme.md requirements and maybe something about contributing. And then there is this is the main package. This is where all of the goodness happens. So you have app.py. This is also a module that people can install, import. There is a score module, and then you can have other sub directory later on. When you create something like graphing, you can have graph. You have something for visualization. You have visualization. You have other things that you want to put as part of the package itself. So this is kind of the main package. Within it, there's app.py, score, utils. All right. So let's go ahead now. Just do our Python again and run that. Okay, now it works. So far so good. It doesn't do anything very fancy, but it would just go ahead and print all this stuff. Now you realize that if you go to app.py and you say that score_accum is run, and it executes this, but at the very end of it, it says if name equals main, you should do all of this stuff, but it's not actually doing that. So now why is that? Well, the reason is because we're no longer running this script directly from here. So this is if name equals to underscore dunder main dunder. What this line is saying is that if you run the accum.py directly and not from another script, not from app.py, not from another entry point, if you run it directly, then do this. So because we're not doing that, we're actually doing it from app.py. So these three lines of code is actually being ignored right now. So that's actually not the way we want to have it. So what we want to do maybe is to just change all of this up and just say, okay, take this two, and you can either just move them up here like this. And so what it does is that if name equals to main, then you run score_accum. If not, this doesn't get executed. But here the rest of the stuff is still gonna continue to run. Okay, so that's gonna be okay, I guess. And we're just gonna have to save that right now. And let's go ahead, run Python task1, and there we see it, the score sheet, the productivity report right there, printed there. This probably makes more sense if you move it all the way to the top. So let's go ahead, Control K, Control X, and we can have before the tables are printed. So maybe before this. All right, then we save it and execute that again, and we see our score sheet, productivity report, and then we see our nice little table there. Okay, so now that we've made those changes, if you want to, you can go into your Vim or no, your bash or your G shell, whatever shell you're using, and maybe change that in your alias as well. So if you follow along the last video in our bash shell or G shell or a bash profile or what have you, you set up your aliases, and I taught you how to do that. So this is kind of a nice time to pause the video and just change that and point it to because the old location no longer exists, right, after all the refactoring that we did here. So what you want to do is to point to the new file and just run from app.py. So that should be what your alias is doing, right? So you alias that, and you said, well, if you name it tscore, taskscore, then you want to have taskscore now alias to app.py instead. And if you're still wondering what is all this refactoring for, now the only difference here is that application code is now all held in the, first of all, it's all held in the task1 subdirectory. This is good because, and as a convention, we name the task1, we name the subdirectory after the main directory, after the parent directory anyway. So the project is called task1. It's just convention that we will name this after our package and just call it task1. So if the name is ABC, you name this ABC. And then we added a file called init.py. The purpose of init.py, it has many different kind of uses, but for our purposes, what it does is that it just tells the Python interpreter to interpret this directory as a package directory. So if if our code want to call this as a like import score itself, it can, because it now recognizes that as a package directory. And you can set up this init.py file in a way that enables you to import classes and stuff. You can go ahead, because it's still a Python file, you can go ahead and just import whatever you need to import from here. So for example, you can import a qm.py directly from here and stuff. You can do that as well. We're not gonna have to worry about that right now, but you can actually set it up that way instead of actually knowing the internal module, the full internal path. Anyone can just say task1.score and just import whatever they need instead of having to go to task1.score.accum or score or utils.colors. They can just call .utils and they import everything. So init.py can do all those import by default, so that they don't have to find the full path of that. So some of this stuff you can maybe tinker around, but for this series, at least for this episode, at least we're not gonna try and do too much in it. We're just gonna keep it that way, the way that it is now, and it really get us halfway to what we want to achieve anyway. So with that said, we can't talk about best practice without at least mentioning about tests. So what we want to do is to actually create a folder, create a directory, and call it tests. And it's conventional to just name it tests. I know you want to probably name something else, but this is a good convention because a lot of CI/CD tools, continuous integration tools, when you deploy that in the production and stuff, they're gonna look for this file, or look for this directory. So we store all our tests into this own directory called tests. This is a pattern that you come to recognize a lot, you come to see a lot, and you will see we continue to use this pattern as well as the task1 structure gain more complexity and becomes a bigger project. Now, if you want to follow absolute best practice, then you also want to split your test into separate modules. So within test itself, you want to have score. So and then within test, you want to have utils and all of this. So all the tests itself should be under separate modules, mirroring the package structure. So kind of have a mirror of what the package structure looks like. So if there is a module there, you want to have that in the test as well. So instead of having one massive test.py file trying to test everything in there, it's better off to break them that way, each corresponding to one Python module in your package. Now, I will say that we may not have time to go over all of the tests in this episode, but it's something we'll get to perhaps maybe in the next episode. So let's go back to accum.py and see where we have where we left off the last time. Now that we already have our color functions in here in the text style, we probably want to use that. So I want to go and take a look at where we stop off in tabulate. Now this is the print statement that we have, and there is the combined headers that we created up here. So I feel like this is kind of a nice time to actually maybe change the colors of the combined header and to give us something more variety. So right now it's kind of plain, right? It doesn't have any fancy effects or anything like that. So we can actually change that and make it a little bit more fanciful. And so let's go ahead and say combine all headers, and we will call a map function. In Python, you can do a map. And I know that if you use pandas or numpy, there are ways to work with this list, and you do something like .apply, and you can then apply x and apply a function like that. But since we're not doing any numpy or pandas, we're just gonna use vanilla Python. Then I think the right way to do it is to just use map. Map takes two arguments. The first one is a map function. What function do you want it to run? So you can write a function up here you can write a function up here and then you can import that, or we can just use a lambda, which is an anonymous function. Just said, okay, just do something already. And then the next one, the second argument is what is the object, what is the subject of this map function. So what do you wanna apply this to what, right? So this is our function, and the second one is just gonna be this. So we're gonna say apply something to the combine L headers, and then give the output of all of that. The output of this is still gonna be a iterator, so we're gonna just need to change them to a list as well. So we're just gonna put them into a map. Now we haven't really written the func, so let's go and do that now. So I'm gonna just go create some space for us, and just to hide away the sidebar, because I know this function is gonna be kind of long already, and probably this one goes down to the next line as well. And then I'm gonna just say lambda x. So a lambda function is kind of just an unnamed function, an anonymous function. Almost every programming language have this. And what we're gonna do is we're gonna use some f string, some fancy f string. Now I still wanna have my formatting, but I would know first that whatever I pass into this, so each one of this, date, score, cumulative, iteratively they're gonna be fed into this function, and I'm just gonna call them x right now. Okay, so I wanna put the x in here, and then I wanna maybe reset the formatting. So how do I reset the formatting? We learn about that. That's the dot reset. So let's go ahead and make it bold first. So let's say text style, and I want to say dot bold. So that's gonna make it bold. And immediately I want to just end the style. So text style, and I want to say reset to just say, okay, that's when you end. Okay, if you do nothing else at all, this will already give you the bold effect. But I know this is not what I want. I actually want to have the underline as well, and I want to have the change of colors as well. So I want to just say text style, and I want to say underline. And here is also where I want to put the color. So text style, and there is a color called OK Cyan. I'm just going to call that, just do it like this. Now combine L headers is going to be the map function is going to run on it. Run what? This. So it's going to run on combine L headers, this function, and then the whole thing is just going to be output as a list. Because of this list, it's going to just do that, and then you're gonna name it something else. You can name it, you know, formatted, right? But I'm just gonna replace combine L headers because I will never need that anyway. So I'm just gonna say that, and that would then print it out to the two of them. Okay, to the two print statements here. One is a tabulate, one is a create table. So let me just save that real quick, and let me just see how does it look like right now if I just do nothing and just run a Python test. task1 app.py, scroll up, there we go. So now there's the bold effect, the underline effect, and the color effect. Okay, this is looking okay. It does all of this for us already. Now what about if we were to look at the create table, meaning if we have a vanilla Python, we don't even have tablet installed, how does it look like? So if you do a deactivate, and then you try and run the same thing again, now it's doing the same thing up here, but it's not actually formatted. The tabs are not, or that the spacings are not actually done correctly. So I'm gonna go ahead and change the way that my create table is run right now, and then from there I'm gonna just simplify this a little bit so that it has at least it does the right thing for us. So let me go and click into create table. So control pre brings up this quick search bar, and I'll just punch in create table.py, and it will search the create table.py file for me. And within it, I'm going to change a couple of things here. So instead of doing all of this fancy stuff, I'm not even going to do that now. What I'm going to do is really simple. I'm going to say that, okay, if there is a header, then you want to print a header. If you don't have a header, don't worry about a header. I want to make sure that create table is generic enough that if there is no headers, you shouldn't stop the function from running anyway. So I'm just going to check. If it's there, do something. And I'm going to just remove all of this as well. Just have the if headers check. And then I'm going to say first print the header and then print the rest of the body. So I want to have the text here, and then I want to tap them. So I'm just going to give it a simple string. So header string. And I want to basically say that first, for each one of these items, pass a tab, and then put the item, and then tab again. So tab, to escape the tab, I'm going to say \t, and then whatever it is that is in there, and then \t. And it needs to repeat how many times? Well, it depends on the length of the header. Well, you would be tempted to write 3. You don't do that because that is not going to be generic enough. You want this to be generic enough that anyone can call the create table, pass in a sensible header, and you should still be able to figure things out. So instead, we're just gonna set the length of the headers. So if the length of headers in this case it will be 3, then it will just repeat 3 times. It will just then create this nice format. And then what we need to do is to just pass those things into it. And we can do that very easily using a print and then using a format. So we just have to say header string like this, set format, and then we just have to unpack the list, because if we pass in a list, it's gonna try to put all things into one. So we just say unpack it. And in Python, to unpack it, we just use a asterisk like that, and just say headers. And so that would just create the, if there is a headers, it would do that. If there's no headers, then just ignore that and just move on to the next thing. And the next thing is to just create the same idea for, instead of header string, we now have the row. Each of these is a row. We want to use the whole row string. So very similar to what we've seen up there. And I'm just going to say, again, the same idea, just copy that, just like this. And I can just multiply by, now, you may be tempted to do 1 to 3, but again, you don't want to do that. Instead, what is the best way to make this more generic? To just check for that, right? So the length of, not the headers anymore, because this is the row string. So you want to take the first row or the last row or what have you. So we just have the first row, 0. And then we just do the format. And in here, we need to maybe go through a for loop, because each one of them needs to be printed out one by one. So if we only do it once, it's only going to print out this row. And that's not nice. We want to print out all of that. So we can say something like for row in table. And we're going to say print. And this is the same idea that we have up here. Just say row string dot format, and we want to unpack the 3 values into each one on its own. So we're going to just say row, just like that. Okay. If you want to, what is this actually doing is kind of similar. This is actually the equivalent of doing this. It's kind of the equivalent of taking this in here, and then here you have row 0, and then you have the same thing, copy it, because you multiply that by 3, so you have row 1, kind of the equivalent of that. And hopefully you get the idea. So that's kind of it. That's our create table. So let's change the create table up, and now it looks ugly, but let's try and work on live OS. So we go into the virtual environment that has tabulate installed. Now let's try and do that. Okay, so everything still works, nothing gets changed. But what if we deactivate it? What if on a vanilla Python, where there is no external dependency, no third-party dependency, what does it look like? So let's do that. Now it looks a lot better because it's at least aligned properly. You can still arguably come up with new ideas to change that. If you have a better idea on how to format that, you can leave a comment or reach out to me, or maybe send a pull request, and I'll be happy to incorporate your changes in here. Okay, but for now, I'm not gonna focus too much on that. I think that this is kind of, this is good enough for the purpose here. So with that said, let's move back out to app.py. And now that we have the 2 items, I want to do probably one of the biggest change in the entire part of this episode, which is to introduce an argument parser. So I want to have the end user be able to specify a path to the task file. Because if you look at accumulative.py, we haven't actually done that yet. It's still hard-coded in here. So this is not good. We actually want to have the have this not be hard-coded, but be taken on as a optional argument. If it's not provided, then just do something that is sensible. Pick a sensible default value. All right. So that's what we're going to be working on now. Okay. So the first change that we need to make is to move this TaskWarrior. Is to move this all the way down into the function so that we have nothing out here on there. There's no global variable. Everything is properly scoped in here. We can even just create a class for it. Maybe we'll do that in the next episode. But for now, this is good enough. This kind of gives us what we need. We can give it a doc string just to be compliant with all the nice best practice here. So we're just gonna say create a scoreboard using score attribute of task. All right, and what we actually want to do is we want to pass this data location. We want to actually take this as an argument and fit this back into TaskWarrior. So what there are a few ways to think about this, but I like to just put a task path here first, and you can then set a default value, something like this. So take this and change it from here to this one, and you can change this to task path. And this is one way to sort of achieve what you need. Okay, so you have TaskWarrior, you set data location equals to whatever it is. So score accumulative is gonna, this is gonna have to call this function is gonna take an optional argument. Why optional? Because if that is not specified, then it's just gonna run with the default value here. Okay, so you want to have some sort of default value in here. But I know that in TaskWarrior, the default value is actually going to be called .task. That's the default value. From reading up the documentation, if you don't believe me, go ahead and download a copy of TaskWarrior, and without changing anything, or just read the documentation, it will tell you that the default one will be in the home directory. There's just going to be a hidden file .task. All right, so that's one way to do that. Another way to do it is to go into app.py and pass this task path in here. Right, so just to show you how it looks like, let's open this side by side. All right, so I have this open up on the left, and this is my app.py. This is the entry script. Okay, so what we're gonna do is we're gonna actually specify a task path in here, and this is gonna be the default value. So we don't need this in here. I'm gonna take this out, and we're just gonna pass this into app.py. And just by making this change, you know that things are going to break now, because that is not actually where I store it on my computer, but this is the default location. So I want it to break anyway. So if I now go ahead and say app.py, it's going to tell me that, hey, it runs all the way down. It says list index out of range. It's not doing that. Why? Because I don't actually have anything in here. There is no such file, no such folder in this path. Right? So I need to find a way for end user, for anyone who's using our tool, to be able to specify their own path, wherever it is that they want to set up. All right, so now it's complaining an error, and maybe this is not the best of error, because first of all, it goes all the way to line 45 before it even throws something. It says at line 45 it's not able to do this because there is no list index out of range, meaning it tries to subset this, but this doesn't exist because there is no 0 on this. Maybe this is a none, right? So what I'm saying here is that maybe act date is actually a none, or maybe it's actually gonna be something like act equals date equals to 0, equals an empty list. If it's an empty list, you try and do something like this subset, it's gonna not work. So I'll show you what I mean. If I say this is X and this is just an empty list, and if you try and do something like 0, it's gonna say list index out of range, exactly what you see here, because you can't index 0 when the list itself, this is out of the range of this. It has nothing in here. So that's kind of what I mean in here. So the problem here is that it takes us all the way up to line 45 in order to even realize that it says here in line 45 list index out of range. So that's probably not a good sign. What do we want to do here? We want to actually catch this error very early on. So this happened because there is either, it's one of two situations. So let's put a comment here. It's one of either two situations. The first one is that there is a folder, but it's empty. So there is such a folder. This path is actually a correct path, but the end user haven't actually created any task yet, or haven't completed any task yet. If the end user have not completed any task, then it will not make sense to continue to do all of this, before it hits the exception here that says index error, list index out of range. We probably want to catch that very early on and say that, hey, there is no, well, you haven't really used TaskWarrior in a long time, or you haven't really have any completed tasks, so there's nothing here to perform all this group by aggregation. All right. Then the second scenario is that it's very simple. It's just a wrong task path. So it's just a wrong task path, invalid path. Instead of wrong, let's call it invalid. All right. So it's just either one of these two situations, right? Now, in normal circumstance, if you know that this could be an invalid, then you can just go ahead and throw an error. Just a quick comment. Throw an exception, and basically terminate the project. Just halt the project, throw an error, say, hey, you can't do this. This is an invalid task path. But because we need to account for the first scenario, what if this guy is not doing something wrong? He just that he haven't really created. You just want to warn. So if this is the case, you don't actually want this to be an error. Yes, you actually want this to be just a simple, maybe a friendly warning. A friendly, nice, welcoming, accommodating, human-friendly warning. That's what you want to have. So let's go back into the accumulative.py and see how do we improve this? How do we create a simple warning that says that? So I'm just going to go up here and I'm going to import warnings. So this is probably something new as well to you. If you've never seen this before, this is Python part of the warnings subsystem. So what we're going to do is to use the warnings to create the warning and tell the user that, hey, it could be one of these two situations. Now, I'm not going to throw an error because I don't know if it's one or if it's two. So what I decide to do is that because I have no way of knowing if it's 1 or 2, whether the case is the first case or the second case. We have no way of knowing that. We're just gonna give a friendly warning and ask the guy to check and say, hey, you know, maybe you have an error in your task path, or maybe there's really just nothing. Okay, just let this delegate this decision back to the user. All right, so let's go back up to our accumulative, and we don't want to hit line 45 before doing that. We want to maybe, okay, TaskWarrior completed, and maybe this is a good time to insert a check and to say, hey, hold up, if you check that there is no completed task, then maybe all of this doesn't make sense anymore. Why do you need to proceed with all the different, you know, all this group by aggregation and stuff? So we could do this. We can say if the length of completed, if it's 0, or you can say if it's lesser than 1, so that would be 0. It's only one situation where it's lesser than 1. Cannot be a negative value in here. So we just want to maybe put the warning out there, right? So we just want to print a warning. So you can either do a print warning, but I don't actually want to just print, because print is just going to print and then it's going to proceed to do the rest, because warnings is just a warning. It's not an error, it's not an exception. Error exception is going to throw an error and just halt the execution of the project. A friendly warning is not going to do that. So if you just print it, it's going to continue and go ahead and continue to execute the rest of the function. So what we want to do is to just return the warnings .1, and that's one way to just make sure that it doesn't continue to execute. You just return. All right. Then we just have our own warning in here. Just say a nice friendly warning, and we say maybe something gentle, something nice to tell them that, hey, I'm not sure if it's the first case or the second case. So you can have something like saying that, hey, this is a curious case of 0 completed tasks. So there is no task I can find in this path, and I'm not sure if it's the first case or the second case. So you can say maybe you want to check whether or not you have the right path, or whether or not you have indeed 0 tasks in there. So you want to say check your path, and maybe here we can put in another one to say check the task path to make sure it's correct. Okay, so this is where we have to use the double quotation to make sure it is correct. Or you want to say that check to make sure that it's correct, or go ahead and complete some tasks in TaskWarrior. Just like that. But remember, we have the colors formatting, the text module that we can use. So let's go ahead and just maybe put in a format in here. All right. So we can go ahead and say text style, put a warning to make sure it's correct, and then we can end text style reset. All right. So let's save this now. I'm still gonna get an error, but hopefully this time the error is doing something. It's gonna be a lot more helpful than doing this, because if the end user is looking at this, somebody who is not the author of this package, he's gonna look at this and he's probably not gonna figure out what is wrong here. Like, what does this list index out of range mean? It's not a very good customer experience. It's not a very nice user experience. How do you create a better user experience? Give better feedback, more focused feedback. So let's run that now. Okay, now we have the user warning. It says a curious case of 0 completed tasks. Check this to make sure it's correct, or go ahead and complete some tasks in TaskWarrior. And this is fantastic. Why? Because if I hit Control click on this, it's gonna open that up in a folder, and I can immediately see, oh, there's nothing in there. Okay, so I put in the wrong path. I will know that immediately. Or I will make sure that if this is not the case, then I will just go and just complete some tasks in TaskWarrior. So if you haven't completed any tasks, you won't get any score. If you don't get any score, then you have nothing to show for it in terms of the score sheet. So that's kind of immediately when you do this, you get a much better feedback already. You're giving a much better feedback already to your end user compared to this, which is a lot of gibberish. For somebody who is not writing accumulative.py or not writing the function, he has no idea. He or she have no idea what to fix here. What do I do here? What is wrong here? What is the actionable item in here? This, on the other hand, is very actionable. It's saying that, hey, here's a case. Maybe there's not an error. Maybe it's just a warning. But maybe try and complete some tasks in TaskWarrior, and then it doesn't proceed to continue to run the rest of the code. It just exits. It just return. Some people like to do this print and then they do a return like that. I really don't see why you want to do that right now. I think the one that I just showed you is cleaner. Just return the warning and that's it. But obviously, if you want to, you can do that as well. So this will also work. For example, return, save it, and it's doing the same thing. So now you're using the warnings module to actually print out a human-friendly warnings. Now let's go back to app.py and see what else do we need to fix here. So I'm going to remove all of this comment. This is really just for you. So I'm going to go back to app.py, and now I want the user to actually be able to specify their own path. So I want somebody to be able to call this and then pass in their own path and say, okay, hold on, I don't actually have anything in here, but my correct path, the correct path where I'm actually storing my task is in this location. So the way you do that, in the past you would, if you've been programming Python for like 10 years, you probably heard of argv, but that's not recommended anymore. Instead, what we're going to do is we're going to do argparse. Okay, it's a more modern solution. It does a lot more than argv, and we can slowly look at what are the different features in here. So argparse stands for command line parsing. It stands for argument parser. So if you hover over it, you say this is a command line parsing library. This is a module that allows you to create command line interface that handles input, handles optional positional arguments. So you can create a parser that says, hey, you can pass in a few optional arguments here, a few positional arguments here. The difference between them is if I run this and I put something like 1, 2, 3, and then I have something else like X. Now here, I'm not actually using any kind of name parameters here. So this is completely positional. I'm saying that the first position, take the first position, then the second position. But if I actually want to have something like P, then this is something that says, okay, the name of that. This is a name argument. So I'm saying that, okay, the argument, P argument, this is the value of P argument, and then if I have a dash V, then that is the value of dash V argument. And you can also have more, like it also produce more helpful messages and stuff like that, help message and stuff. So these are definitely very critical to any kind of client-facing CLI terminal app. So how do you use argparse? Now, almost always the first thing you do is to actually create the parser itself. And so let's create an instance of the parser by doing argparse, and we say argument parser. Let's spell that correctly. And I usually just leave it almost empty with just one item in here, just description. So just have an argument called description, and then here is what you just describe what is the project doing, what is this app doing, or what is this sort of parser doing. So just to give it a bit more space, I'm gonna just drag this window out a little bit and just have description. So I'm gonna say CLI utility that extends TaskWarrior for productivity scoreboards, something of that sort. You can have your own description, obviously, but I'm just gonna keep it like that. Later on, if we add more features, for example, maybe giving you a few badges if you achieve this productivity, or if you hit some sort of streak, we can do that. So maybe you can have like make gamification. Okay, so you give it your own description. And then what I want to do next is I just want to start to accept arguments on this parser, right? So the way I do that is I say, okay, so add an argument. Now the first one is I imagine that the end user is going to do this, and then going to specify where exactly is the location of the task. So I want to take this, and the way I do it is I can give it a short. I can give it this flag, say the -p flag. I can give it a longer name here, which is still the same thing. This is the name, but the name, let's just say path, then the flag is just -p. So this will work, this will also work, okay? But if you want it simple, you can just have both, right? -p, -p will also work. And then the type. And the type is where you put things like string, if this is supposed to be a string. So if this is supposed to be a string, if you want to have a number, so you want to say, let's say we create a calculate function, calculate.py, and then we have 10 plus 4. Then this would be an integer. It doesn't have to be, it can be anything in here. But the type itself is saying that what type should this argument be. Alright. Now we don't actually have task calculate, so let's just keep it there. But now let's just put a string here first, but we'll try and improve this. There must be a better one than string. And you want to give it a help message. And here, this is just a simple help message. If the guy is trying to use your CLI, there should be a one-liner ideally saying that, okay, what should this P flag do? Or what should I pass to this P flag to get the desired result? So in this case here, I'm just going to say this is the path to your TaskWarrior .task file or folder. Okay, so this is just a path to your TaskWarrior.task directory. So that's about it. And now I can go ahead and just print the parser arguments. So let's, before I print that, let's just create the arguments. Let's just collect all of them. So args equals to parser, and I say parse all the args, and then I can just print that out. Okay, and you can either do that, or you can skip ahead and see it from my screen. But I'm just gonna go ahead and just show you what it looks like first. So I'm gonna just say -p, and I'm gonna give it some name here. So some text, and you will see that, hey, a curious case of 0 completed task, but then it will say return warnings.warn namespace path equals to some text. All right, so it's actually taking it's actually accepting the user argument, and it's returning that back to us. And so the way we want to actually do this is we can say args dot the name of this. What is the name of this? The path. So we want to just say args.path. And now if you go ahead and run that, now it just returns the some text. Okay, if we run it something else, now it says it prints out something else, and this is all the results of the args.path. All right. So there is also a tiny little problem. I mean, for the most part, you can actually just say, what if I just go ahead and just pass in the right path? And instead of .p, we want to actually say the path where this is at. So I have what's. This is the correct path. Let's see if I run that, what would happen. Now it goes ahead and say, oh, I tried to run that, but this is a text. And it's actually not doing what I want it to do. Okay, so this is the text. And so what we need to do is to pass this into the score accum. So let's bring this down all the way at the bottom. Okay, and just to make things consistent and nice and standard, let's keep it to the name equals to main paradigm, and we can just tap this in just like that. We say that, okay, first of all, see if there is something in here, because if the user doesn't pass anything, it returns a none. So if it's a none, then fall back to this value. Okay, so we're gonna say fall back to this value if it's a none. But if there is something, then you want to take the something. So this is kind of how we do it. So we're saying that, first of all, if we can actually parse the arguments of path, you want to take that value and you want to feed that into score accum, which is from here, which is going to be fed into the TaskWarrior data location. But if you can't find anything, then this is the default value. All right, so this is the second way of doing it. Now the first way is to just obviously remove all of this and then just pass this into the default. So just pass it like this, and then you can just pass the default value in here, and then you don't have it here. That's also one. Or you can just do it like this. All right, so let's go ahead and run that. Okay, there is nothing in here, but if we add a path, now it works. And this is exactly what we want. So there is no more warning error message, but it gives you the correct output, right? Let me really quickly go and change up the score sheet and productivity report. I think it's kind of redundant to have both of them. So I'm just probably going to remove one of them and just keep the second one. And now if we print go down to the terminal and run that again, and we'll see that there is only productivity report. So this is kind of all we need. And there is also the path here that is printed out for us. So this is probably something we don't need now. We could remove that. And that's kind of it. This is a way to just say, okay, if the person passed in a path, so at least we accomplish what we need to do, which is to set up an argument, a parser, allows the user to specify their own path. And then in your alias, you can then specify that to your own path. But if you don't specify one, it defaults to the default location. All right, and it doesn't actually throw a hairy warning for you. We just give you a quick a quick feedback saying that, hey, it may be the case that you are passing in the wrong path, or it may be the case that that is in fact the correct path, but you haven't actually created any task, or you haven't actually completed any task. Okay, so just to help you make this idea a little bit more clearer, let's also go ahead and just add a second argument. Let's also say that the user can also optionally have a second argument, and we're going to call this the verbose flag. So basically give the user a choice to want to print more information if they want to. And we can then have an action, and this is just going to be a boolean, so it's going to be either true or false. So we're going to just say true or false. It's just a simple true or false, and this is basically the help message is very simple as well. We're just going to call it verbose mode, just to have more information if you want to. And now we can then say if the person passed in a -v, what do we want to do with it? So in the case of -v, for example, we can go ahead and print out the name of the files as well. So this is where we can actually say something like print again if args.verbose equals to true. If this is verbose, then go ahead and print the message out and say this is your task path. Put an X flag and say this is the task path, and we then have our task path being this. But of course, we can bring in our color and make things a little bit prettier. So let's go ahead and just import our utils. And from here, we can just go ahead and format that so that it looks a little bit better, right? So here, I'm just gonna put a style, and I'm gonna style it text style. And this is just gonna be my bow. So I'm just gonna give it a background and make this bow. And then I'm gonna try to end this here. So text style reset, which is saying that okay, that's when you should end. And then I also want to make sure that the rest of the text just appear with a different color. And so just gonna maybe put a text style, and let's say with a green color. The green is called OK green, and I also want to reset here. So text style dot reset, and that's it. Let's go ahead now. Let's see if the verbose mode works or not. And we didn't actually put the verbose flag, so which is why there's nothing appearing. Put -v. Now it appears task path. Okay. And if you want to have more verbose, if the user choose to have more information, then they should be able to see more information. So you give this a choice. You give this guy a choice. If the -v flag is not there, then just print out what it's supposed to print out anyway. If you put a -v, it says okay, turn on verbose mode, give you more information. Now a few other things I can actually print out as well. But before I do any of that, there is still something bugging me. Is this string here? This is not actually a string. This is actually a path. So I actually want this to be I want this to be more accurate, more semantically accurate, reflecting what it really is. So what I'm going to do is to create a helper function to check whether this is actually a directory or not a directory. So to do that, if I show you what it looks like in Python, if I do import OS, there is this thing called the OS submodule. You can say import OS that get working directory. Okay, so get working directory is just going to give you what is the current directory of where I'm at. So just to give you a sense of what we're going to be doing, we're going to use the OS module to sort of detect whether this is a directory or not a directory. So we can go ahead and do something like os.path, and we can say, is this a directory or not? And we just have to copy off this, just Ctrl-Shift-C and then Ctrl-Shift-V. It says it's true, it is a directory. But if we put in something nonsensical, 2998, then it's a false. That means, hey, this is not even a directory. There's nothing in here. I can't find that path. It's not on your OS. Okay, so we're gonna use this nice little trick to actually check whether this is true or not. So why don't you go ahead and create a new file. This is a good time to put it in utils because this is all under utilities. These are all helper functions anyway. So let's go ahead and just create a new file, and I'm gonna call it a helpful scripts. So this is where all my helpful scripts are gonna be at. And just from the earlier demo, I know exactly what I need. So I need OS. So I just need to go ahead and just import OS. So let me do import OS. And then I want to say define directory path. And I want to take a string. And I'm going to check whether the string is this. Just going to say pass here. Check if the string is valid path or not. Okay, if it is, then return true, return the string. If not, just throw a warning again, throw an error. Okay, so this is a time where we could just repeat what we've done in the terminal, and we just say if os.path is there, is this a directory or not? Put a string in here. If it is, just return a string, nothing else. And now you can do an else, and you can then choose to return a warning. You can say, hey, return a warning, and say, so let's go ahead and bring our warnings. And we can say warnings.warn, and give it a warning and say this is not a valid directory. Or you can have a f string, and you can say string is not a valid directory. You can optionally then pass in a second, like a warning type, right? But I would then argue that maybe this is not the right time to use warnings, because this is not a warning. This is clearly an error. This is clearly not the case. You know, the case for that is to make an exception or make an error. So we probably don't want to use warning here, because this is, you can actually just do that. You can keep to this code and just not change anything. But I want to actually say that I want to actually remove all of this and say that this is a time to actually say this is not a directory error. So when I can just say raise not directory error. So this is going to raise an error, and you can then optionally pass in a string, and I can just say that's the string. So what this is going to do is that if we pass in a wrong path, a nonsensical path, it's going to just throw an error, and it's going to tell us, okay, this is the nonsensical string that I received. Okay, so let me go and save that and quit this out from a terminal. And within app itself, let me just go and test that out. Okay, if I continue to put in a path, and let me just pass something that is nonsensical. This clearly doesn't exist in my file. I'm going to see if it throws an error. So to do that, let me just go ahead and import all of this stuff from my helpful script. So from the helpful script itself, you can put it in here and say from utils.helpful import, what did we call it earlier? We call it dir path. So directory path. And within it, all you need to do is to make this change to dir path. And now let's hopefully run into an error, because that's when we know our code is working. And hopefully, you know, later on we create our test folder, and we put all our tests in there anyway. So with all the tests in there, we can more systematically test this, kind of like what I did in my other videos. If you haven't learned about testing and stuff, you can watch my other videos. It'll show you all of this, all the testings, and all of the, you know, good things about using PyTest and stuff. But for now, this is good enough. Let's just do a manual test, run it, and it does raise a not directory error. This is good. See that? So if we pass in a path that doesn't exist, let's say we mistakenly spell this as what.task, then it's not gonna continue to try and run all of this stuff, but it's actually gonna raise the not directory error, and it's gonna give us what we just enter here. So they say, oh, we forgot an S. Fix that. Now it's running. So this is great. Now let's actually format this a little bit. This is actually all the import, all the Python modules, all the main Python standard libraries, and then these are all our helpful modules that we just import from. So just put the whatever is from Python standard library, just put it up at the top, and then followed by all our submodules. So we're gonna do that this way. And then there is a verbose argument. Let's actually make the verbose a little bit more interesting, because if we currently run verbose, it prints out the task path, but it's not a lot of information. The verbose doesn't add a lot more value than the non-verbose version. So let's maybe pass the verbosity flag. Let's say create something called verbosity, and we say this is actually just going to be the args.verbose. Remember that the name has to be the same as this. Okay, so the name is verbose, so let's name it verbose. So if this is a true or false, and that's gonna, if it's a true, then the verbosity is gonna be true. This will be passed into score accum. So let's go into score accum, which is here, and let's handle that case here. So let's put verbosity in here, and you want to make sure that you save both. And now it says that if the verbosity flag is on, then go into then score accum should have verbosity as true. And we want to say that if verbosity is true, then you want to print a few more useful information, a few more helpful information. So we can go all the way down at the table to the table, and we can say that, okay, if tabulate is there, print the table, but at the end of the table, maybe just after the table, I want to print a few more information here. So if the verbosity flag is true, so we can say verbosity. If it's true, then you want to print some extra information here. So let's go ahead by starting by let's go ahead and start by printing out the total completed tasks. How many tasks have you completed in order to accumulate a total score of 87? Okay, so let's go ahead and say print, and we're gonna use an f string again. Just to give it a bit of a consistency, I'm gonna just have the same thing like text style not bg2go. Just gonna copy that, and then I'm gonna just have a total completed task. Okay, so total complete the task, and from here I just want to have a quick reset just to remove the effect. So I'm just gonna take the text style, dot reset, and then I'm gonna put the number of tags in here. And because in this I'm using green, so I'm also gonna keep to it and use green as well. So let's go ahead and just pass the green. And then this is where we want to put a total completed task. Let's put 100 for now. I know that's not the right answer, I know that's not the correct value, but let's just put a placeholder, and we just want to reset. Okay, if this all seems tedious, you know, you get used to it. So now, how do we find the number of total completed tasks? Is there somewhere in here that we, is there somewhere in our code that we can find that value? Well, it turns out there is, right? Because at the very beginning of the script, we say that this is the completed, and we say if the length of completed is less than 1, then return this. So I can just go ahead and just do a length of completed, but now I'm going to be counting length of completed twice. So in terms of thinking about, maybe this is not a big deal, but if let's say the completed is actually growing to a massive amount, then the length of that, even no matter how fast it is still kind of unnecessary to do it twice. So maybe what we can do is to just take away the computation and do the computation only once, and we can say, we can have something like total completed, and we can have the length, and now we don't have to do the computation twice. We just store the value here like this, and then we can reuse the same value right at the bottom. So this is just some of the way I like to think about my code anyway. So I'm just gonna change this value and pass it like this. To test that all of this works, I can just go ahead, run it, -v. It says has no res because we did not spell reset correctly apparently. So we miss out the E in here. Save that, come back in here. Now we have the total completed task. Great. So this is the verbose flag is giving us a little bit more information now. I want to add a space between the values, so I'm just going to put a space in here. And now I have 44. There's a space. That's okay. And I maybe want to have something like how many days am I active actually, right? So how many days have I been active? What about the days that I'm not active? For example, 13. What if I have no task on 14 that I've completed? So that's going to be a 0. And so that shouldn't count towards it. So I want to maybe have something like what is the number of days where I'm actually active? So let's go ahead, and if this is verbose as well, print that. So again, use an f string, and this should be very similar. So let's just go and copy almost all of this. So Control L to copy the line, and then Control C to copy, Control V to paste. I'm going to change the background from BG2 to BG1 just to have a slightly different, you know, a little bit of variety. And I want to say active dates. How many days have I stayed active? Because that's kind of nice to know as well. And then within it, I want to maybe have the OK green is good. I'm going to keep that. But now, what do I have in this? What do I have in place of total completed? So now it's the total active date. So if you scroll up a little bit and try and read through the code, if you write very good code, very nicely formatted code, very well commented code, you probably should spot something that could be interesting to you. So for me, it looks like aggregate date is exactly what I want, because here is before I did the rolling. Because if I do the rolling date and if I do the rolling date itself, that's no longer fair, because I fill all the empty days, remember? So if I have 14 and then I have 16 and I have 17, then I'm going to fill the 14, 16 with the 15 in there. So you obviously don't want to take that, because then you're just not going to get the right values of active date. You're just going to get total days anyway. You might as well just do the end date minus start date, right? You might as well do that. So what I'm going to do instead is I'm going to take only the act date, and this is the aggregated length. You know that this is a list, so it has so you know there's a length of this list, and so what we need to do is to just wrap this into length, and that will give us the right value. So length of aggregated date, just like this. Okay, And if we save this, run it with the verbose flag, -v. Now we have three things. We have total completed task 44, active dates 11, and this. Maybe we could also change this to be, instead of OK green, we can change this to be OK cyan to give it a bit of variety. And all right, that's that. There you go. So you have 44, you have 11, you have that. So that's kind of it. So what have we done so far? If you look into our sidebar again, look at our navigation again, we see that now all of these things is in a proper directory folder. This is kind of a in a best practice directory structure, and we have our git ignore file, readme file, requirements file outside. We have our test file. We haven't really done anything in there yet. We have our test directory rather, and then within it, all of the main ideas, main concepts, main features are gonna be within the task1. In task1 itself, we now created a score submodule. Within it, we have the accum.py, but we also have the utils. These are all the helpful features. Maybe some other submodules are going to be able to use them, so we're just going to keep them separate. But now we introduce a way to have a very client-friendly, very good-looking, handsome-looking command line interface tool. So I'm just going to go ahead. These are all optional parts, but I'm just going to go ahead and just do my alias and set that up and wire that up. So to do that, first thing is to just go to app.py and do exactly at the top, do exactly what you did in the last video. So this is kind of telling your shell what to use to execute this file. So again, we're gonna have our shebang, and then we're gonna have our user bin env, and we're gonna put Python 3. So this is saying that, hey, when you come to this file and I'm asking you to execute that file, then I want to make sure that you know to use Python 3 to do that. And then next is to give it permission to execute that. So you say chmod. All of this happens on the Unix, and if you're using Mac, it should work the same because it's also Unix. But if you're using Windows, probably a slightly different process. And then you just want to give it the name of this file. So I want to just say the name of this file should be app.py. So task1 app.py. So task1 and app.py. If you press tab on the terminal, it gives you sort of like an autocomplete, and you can just cycle through them, right? So that's how you give it execution privilege. Plus X stands for execution, so you give it execute privilege. So I've already done that, so don't have to worry about that now. And once you have done these two steps, then the next step is to go into your set up your alias, and you know how to do that already from the last video. So I'm just going to show you how it looks like real quick. And I'm going to just shrink it down a little bit here, clear the screen, and let me just go to do Vim and open up my G shell because I'm using G shell. If you're using bash profile, you may want to change this to like something like bash rc, or this could be like bash profile. Could be one of these two, but for me it's going to be G shell. So I'm going to just say Vim G shell, Control G to go all the way at the bottom, and then from here just add an alias. So if you're using Vim, just press O, it would open a new line. If you hit capital O, it will open up one at the top, and you say alias tscore, and I can have tscore verbose. Okay, then I just have to copy what I have up there and double click double Y and P. That we just paste it, and then here we can just delete to the end $. Add the V flag, and we just have to say tscore V to give it the verbose. Right? If you want to put tscore, it just give you the normal one. Tscore V just give you the verbose flag. WQ stands for write and quit. And now we are finally ready to see the moment of truth. And let's go ahead and do our source, just to make sure it's loaded to the system. And we can say tscore. Okay, so far so good. What if we are working on with a tabulate in our environment? Give it more space. And repeat the tscore again. Okay, so now it gave you all of the colors. Looks pretty. Give you the underline, the bow, and the color. If you don't have the tabulate installed on your environment, so if it's a clean vanilla Python, it will still work. And now let's go ahead and do something like tscore V. And it prints out the verbose information as well. So that's how you created the command line application that takes on two optional arguments. If you don't want to do that, you can also change directory, go into downloads, and if you want to continue to test your script, you can do that. I'm just going to change directory to task1, and then I can just do a Python, and I can say task1. Now, just to mess things up a little bit, just to make things wrong, let's go ahead and add .py, but let's give it a wrong flag just to see if everything still works as we expected. And we say this is just a, or let's just give it nothing at all, right? It says, hold on a second, check your task to make sure it's correct, or go ahead and complete some tasks in TaskWarrior. Okay, so this is perfect. This is exactly what we want. It gives us a color feedback, and it gives us a yellow warning. So let's go ahead now and just give it a path and give it a wrong path. Something that doesn't make sense, something that we don't have. Downloads task file, something. We don't have this path. Click on that. It says not a directory error, this doesn't even exist. Cool. That provides all of the feedback that the end user need to know in order to troubleshoot that error, in order to have some actionable items to be able to use your app, to be able to use a tool. Cool. Now you provide all of the feedback in a much more friendlier way, and this is a much better customer experience for your application. And you now have all the tools to go ahead and now create a parser, add more arguments, and try and change things up, play with it, add a few more bells and whistles, colors, anything you want. And I feel like this is kind of a good place to put a cut here. And maybe at this point, if you want to just continue to build upon that, all of this code is going to be on my GitHub. Just go there, fork the project, start the project if you like it, and then continue to develop on top of the parser and on top of all the existing functionalities that is already implemented. So go ahead, and if you have new ideas about what you want to do from here, maybe create a nice chart without using any matplotlib, without using any dependencies. That's a welcome idea as well. So feel free, leave a comment and tell me what you want to see next. Talk to you soon.